Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed volume of cylinder and we have solved questions from exercise 13.6. Hope it was clear for you all. In today's session, we shall discuss volume of right circular cone and we will also discuss problems related to volume of cone. Let's move on to the topic. Let's begin with volume of a right circular cone. Here we will find out the formula of volume of a right circular cone. Consider a right circular cylinder and a right circular cone of the same base radius and the same height. So we have to consider a cylinder and a cone with the same radius and same height. There is a cylinder and there is a cone, both are having the same height and the radii also same. And we are going to do an experiment that will help us to derive the formula of this cone from the volume of cylinder. For that, what we have to do is fill up this cone up to the brim with sand and empty it into this cylinder. When we are doing it in the first time, it is not completely filled. Means the cylinder is not completely filled. And then continue the same activity when we are doing it in the second time. Means the activity is fill this cone up to the brim with sand and then emptying it into the cylinder. When we are doing it in the second time, that time also it is not completely filled. The cylinder is not completely filled. Then repeat the activity, and when we are doing it at the third time, it is completely filled. The cylinder is completely filled with sand. So from this experiment, we can come to the conclusion that 3 times the volume of a cone is the volume of a cylinder. 3 times the volume of a cone, because with this cone we are filling the cylinder. First time it is not filled, second time it is not filled, but third time it is filled. The cylinder is filled. So the conclusion is 3 times the volume of a cone is the volume of a cylinder. In another way, if you say the volume of the cone is 1/3 of the volume of the cylinder. The volume of the cone is 1/3 of the volume of the cylinder. We know the volume of the cylinder, that is pi r square h. So volume of the cone is 1/3 of volume of cylinder, means 1/3 of pi r square h. Provided both should have the same base radius and height. So we can come to the conclusion that the volume of a cone is 1/3 pi r square h, means 1/3 of volume of cylinder. Next we shall solve the exercise questions. Exercise 13.7, first question. Assume pi is equal to 22/7 unless stated otherwise. Find the volume of the right circular cone with radius 6 cm and height 7 cm. So here R is given to us, H is given to us. We are asked to find out the volume of cone. So this is the shape of the cone. Radius is 6 cm and height is 7 cm. It is given. Let's write the given conditions. Then volume of the cone formula is 1/3 pi r square h. Let's substitute the value of pi, r and h. That is 1/3 into pi value is 22/7. It is given to us, into r square. R square is 6 into 6. 6 we have to multiply 2 times. Into h is 7. Then here 7 and 7 we can cancel, and 3 and 6 we can cancel 2 times. Let's multiply the balance. That is 1 into 22 into 2 into 6 into 1. So here 22 into 2, that is 44 into 6. 44 into 6 is 264. So 264 centimeter cube. Do the calculation on the right side of your answers. Then radius is equal to 3.5 centimeter and height is equal to 12 centimeter. Here more or less the same process only, but only there is a difference, means decimal number is there. That's all. So multiplication or cancellations we have to do with a little more, with utmost care. That's what we have to do when a decimal number comes. There is a cone, radius is 3.5 centimeter and height is 12 centimeter. R is equal to 3.5, h 12 centimeter we have written. Volume of the cone is 1/3 pi r square h. Then 1/3 into pi. Pi value is 22/7. It is given to us. Into r square. R is 3.5. R square means you have to multiply 3.5 two times into h. H is equal to 12. This type of calculation before also we have done. So this 3.5 and 3.5, there are two decimal values are there. We have to remove this decimal and make it as a fraction. So 3.5 we can write it as 35 by 10, and here also 3.5 we can make it as 35 by 10. How we have got 10 in the sense, when we divide a number with 10, we will move the decimal, or we will place the decimal one digit from the right. So 35 divided by 10 means it is 3.5. That's what we have done like this way. Then we will go for cancellation. 7 and 35 we will cancel and we will write 5. Then denominators are having only 10 and 10, so let it be there. Just we can do the calculation in the numerator. That is, here 1 into 22 into 5 by 10 into 35 by 10 into 4. Then 22 into, here you can see 5 into 4. 5 into 4 is 20. Then 35 into 20. 35 into 2 is 70. 35 into 20 is 700. Means when we are doing these three numbers multiplication mental calculation, we will get 700. Then there is only 22. So we can remove those two zeros. We can cancel with this 10 and 10. That means we are having only 7 in the numerator and there is one more number 22. So 22 into 7 when we multiply, we will get 154. Once again, this 5, 35 and 4. 5 4s are 20. 20 into 35 is 700. 700 is having two zeros. That two zeros can be cancelled with 10 and 10 in the denominator. So only 7 is the balance. Here is 22 is there. So 7 into 22 we are doing 154 centimeter cube. So wherever possibilities are there, just to do the mental calculation, or else everything if you do it, it will be a problem because we will not be finishing it on time. Next we shall discuss the second question. Find the capacity in liters of a conical vessel with radius 7 cm and slant height 25 cm. Here we are asked to find out the capacity. Capacity means volume. Volume of cone. Volume of cone in the sense we have to use the formula 1 by 3 pi r square h. So here r and l is given to us. H is missing. So let's take the given measurements, that is radius r is equal to 7 cm and slant height l is equal to 25 cm, and h is missing, let it be h itself. Then by using the LHR relation we have to find out the value of h. Let's substitute here L square is equal to h square plus r square. This is our LHR relation. Then L, when we substitute, it is 25 square is equal to h square, we don't know that, plus r is 7 square. From here h square we can calculate. Take this 7 square to the left side. So 25 square, this plus 7 square taking to the right side means minus 7 square. So 25 square minus 7 square is, we are doing it in a different way. That is by using a square minus b square formula, we are splitting a minus b into a plus b. A minus b into a plus b when we do, here 25 minus 7 is 18. 25 plus 7, that is 32. Then this 18 and 32 square root we have to take to get h. Then this 18 we can split as 9 into 2. That way we can do it. 18 is 9 into 2. And this 2 and 32 together, it is 64. The aim is to make a perfect square numbers. So 18, there is a perfect square. There is 9 with 18. So just we split it 9 into 2. And this 2 and 32 together we can, if you multiply, we will get 64. 64 is also a perfect square number. So 9 into 64. From here easily we can take out the square root. That is root to 9 is 3 and root to 64 is 8. So 3 into 8, final answer h is equal to 24 centimeter. This is only to introduce a particular method of solving. But if you feel difficulty, just from here you can continue like 25 square is 625 minus 7 square is 49. Then from here directly you can calculate h. It's not a problem. So just to introduce a method of calculation, I have done this one. But you can choose any one method which is convenient for you. Now h we have got 24 centimeter. Capacity we can calculate. Capacity is equal to volume of the cone, that is 1 by 3 pi r square h formula. Let's substitute it. 1 by 3. 1 by 3 into pi. Pi value is given to us here. R square is also, R is also there with us, and h is also, all the values are there. Here r is 7 and h is 24. So when you substitute 1 by 3 into pi value is 22 by 7, r value is 7. So r square is 7 into 7 into h is 24. Let's do the cancellation. 7 and 7 it is gone. 3 and 24 8 times. So we are having 22 into 7 into 8. So 7 and 8 when we multiply, you will get 56. So 22 into 56 when you multiply, you will get 1232. So that is 1232 centimeter cube is our unit. But here we have to find out the capacity in liters. We have learned in the previous class centimeter cube to liter conversion. Centimeter cube to liter means you have to divide with 1000. That is 1232 with 1000 when we divide. Denominator is having 30. So we have to move the decimal 3 places to the left. 1, 2, 3. So the decimal will be coming between 1 and 2. So 1.232 liters. That is the capacity of conical vessel. Then the second part is there. Height 12 centimeter, slant height is 13 centimeter. Here H and L is there, R is missing. That we have to calculate. So this is the diagram. R is missing, H is 12 centimeter and slant height is 13 centimeter. So this portion you will do it as homework. Move on to the third question. The question is, the height of a cone is 15 centimeter. If its volume is 1570 centimeter cube, find the radius of the base. Here pi value is given to us 3.14. So height of the cone h is given, volume is given. We are asked to find out the radius. So let's take the given conditions. Height h is equal to 15 centimeter and there is an unknown radius is there. So let it be r. Volume is given to us 1570 centimeter cube. Volume formula we have to substitute, that is 1 by 3 pi r square which is equal to 1570. And here we have to substitute the values. 1 by 3 into pi value is 3.14, that is what it is given to us. R square is unknown, let it be there, into height is 15 is equal to 1570. Then here 3.14 is a decimal number. We are just changing it into as a fraction. That is 3.14. We can write it as 314 by 100. And in the numerator there is 3 and 15 you can cancel 5 times. It is a mental calculation. I am not showing here. 3 and 15 when we cancel we will get 5. So that 5 is here into r square is equal to 1570. From here r square is equal to 1570 into 100 cross multiplication divided by these numbers 314 and 5. Then r square is equal to 1570 into 100 divided by these 314 into 5. When you multiply you will get 1570. You can cancel these 2570s on the numerator and denominator. We will get the answer as 100. R square is equal to 100. R is equal to square root of 100, that is equal to 10 centimeter. So the radius of the cone is 10 centimeter. Move on to the fourth question. The question is, if the volume of a right circular cone of height 9 centimeter is 48 pi centimeter cube, find the diameter of its base. Here volume is given to us 48 pi centimeter cube. Height is also given 9 centimeter. We are asked to find out the diameter. For calculating the diameter, we need radius. So first of all, by using these two conditions, we will calculate the radius. From the radius, we will know the formula how to calculate the diameter. By using that, we will calculate the diameter. So there is a cone, radius is missing, only height is given to us 9 centimeter. So let's write the given conditions. Height 9 centimeter, radius is unknown for us, let it be r. And the volume is 48 pi centimeter cube. Volume formula we will substitute 1 by 3 pi r square h is equal to 48 pi. Here 1 by 3 pi r square into h is there with us 9 centimeter into 9 is equal to 48 pi. And here both the side left and right side pi is common, we can cancel it. Then 3 and 9 we can cancel 3 times. So r square is equal to 48 divided by this 3 will come to the denominator, 48 by 3. So r square is equal to 16, r is equal to root of 16. R is equal to root of 16, we know the root 16 value, that is 4 centimeter. R is equal to 4 centimeter. So this is the radius. but we are asked to find out the diameter. So diameter is equal to 2 into radius. Double of radius is the diameter. So diameter equal to 2 into radius. That is 2 into our radius is 4 centimeter. 2 into 4 equal to 8 centimeter. So the diameter what we have got is 8 centimeter. Next we shall discuss the fifth question. A conical pit of top diameter 3.5 meter is 12 meter deep. What is its capacity in kiloliters? You have to find out the capacity, means volume in kiloliters. Conical pit of top diameter means from here we can calculate the radius. Deep is there, means depth we can consider as height, 12 meter. So there is a conical pit and the diameter is 3.5 meter and the height is 12 meter. Let's write conical pit height is equal to 12 meter and radius of the pit is diameter by 2, that is 3.5 by 2 meter, that is 1.75 meter. Then capacity of the pit is volume of the cone. Both are same. Volume of the cone formula is 1 by 3 pi r square h. So 1 by 3 into pi value it is 22 by 7 into radius. Radius is 1.75. So 1.75 square. 1.75 into 1.75 into h. H is 12. Then here 3 and 12 we can cancel 4 times. Then 7 and 1.7. So by ignoring the decimal, you can divide first. 7 and 175, it will come 25 times. Here after the decimal 2 digit means decimal will come in the beginning of the number, that is 0.25. Learn this type of calculations. It will be easy for you. Then here 175 is there, ignoring the decimal. Here 175 into 22, when we cancel in when we multiply, we will get as 3850. And there is one more calculation is there, that is 0.25 and 4. You know that 0.25 multiplying 4 means you will get 1. So that we can just completely ignore it, because when you multiply a number with 1 we will get the same number. So these two will be reduced to 1. And here 22 into 1.75 is the balance. That two numbers we multiplied here by ignoring the decimal. So we have got as 3850. Then here after the decimal 2 digits are there, means we have to move the decimal from right to left 2 digits. So between 8 and 5 the decimal point will be coming. So 38.5 meter cube is the answer. That is the capacity of the pit. But here this is in meter cube. Cubic meter is the unit. But here we are asked to convert the unit into kiloliters. So as we know that 1 meter cube is 1000 liters. That means 1 meter cube is same as 1000 liter. We can call it as 1 kiloliter. Means simply 1 cubic meter and 1 kiloliter both are same only. So here in meter cube, just simply change this meter cube to kiloliters, because both are same. 1 cubic meter and 1 kiloliters are same. So 38.5 kiloliters. Here 1 cubic meter is 1 kiloliter. Here we are having 38.5 cubic meter. Means just to multiply with 1. That's all. 1 into 38.5. So 38.5 kiloliters. Or simply you can change meter cube, write kiloliters. Whichever way is convenient for you, that way you can do it. So capacity of the pit is equal to 38.5 kiloliters. Next we have to discuss the sixth question. The volume of a right circular cone is 9856 centimeter cube. The diameter of the base is 28 centimeter. Find the height of the cone. Here volume is given to us 9856. V is 9856. Diameter is 28 centimeter. From the diameter we know how to calculate the radius. First of all we have to find out the height. Let it be h. So let's find out these values. Radius we will get it 14, because 28 divided by 2. Then height we can take it as h, and volume of the cone is given to us 9856. And here volume formula, when we substitute 1 by 3 pi r square h is equal to 9856. From here let's substitute the values. 1 by 3 into pi value is 22 by 7 into r square. R we have got 14. So r square means 14 into 14 into h is an unknown, that is equal to 9856. Then h is equal to 9856. This 3 and 7 we can take it to the numerator here, cross multiplication. So 3 into 7 divided by these numerators will come here. That is 22, 14 and 14 will come here as denominators, cross multiplication. Then 22 when we cancel with 11 here, 2 times 22, the 2 times 11 is 22, and 9856 when you cancel 11 we will get 896. Then 2 and 896 when we cancel we will get 448. 2 we are dividing with 896, we will get 448. Then 14 and 448 when we cancel we will get 32 times. Then 32 you can cancel with 2 16 times. Here 14 if you cancel with 2 will get 7. Then again that 7 and 7 we can cancel these two 7s. So we are getting the answer 16 into 3. Here 3 is the balance, and here 16 we got 16 into 3, that is 48. So height we have got as 48 centimeter. Height of the cone is equal to 48 centimeter. So this is one way of calculation. If you find some other way to calculate, you can just go with that. Cancellation is not a problem. Method of calculation is not a problem. You can approach any way. It's not a problem. Then we will go for the slant height of the cone. Slant height means L we have to calculate. For that R is there, H is there with us. By using L, H, R relation, we have to find out the value of L. Then L square is equal to R square plus H square. That is our LHR relation. Substitute it. L square is equal to, we have R square 14 square plus 48 square. Then L square is equal to 14 square we have 196, 48 square that is 48 into 48 you will get 2304. Then when you add these two we will get 2500. It is a quite simple value. 25 square root we know that is 5. 2 zeros means 1 zero will come out of the square root. So L square is 2500. From here L we can calculate. As I said before, root of 2500, out of this 25, 1 5 will be coming out. Out of these 2 zeros, 1 0 will come out. So L is equal to 50 centimeter. So the slant height of the cone is 50 centimeter. Third one is the curved surface area of the cone we have to calculate. Curved surface area of the cone we know the formula pi r L. So pi RL we have to substitute, that is pi is 22 by 7 into radius. Radius we have calculated here 14 into L. L we have got here 50. Then here 7 and 14 we can cancel. 7 and 14 2 times. So 22 into 2 into 50. Here you can see 2 into 50 you will get 100. 22 into 100 that is 2200 centimeter square. We did not do any multiplication here, rough work, just all we have done mental calculation. So whichever convenient method that you can follow. If you are feeling mental calculation is difficult, write and multiply, it's not a problem. So answer is 2200 centimeter square. Move on to the seventh question. A right triangle ABC with sides 5 cm, 12 cm and 13 cm is revolved about the sides 12 cm. Find the volume of the solid so obtained. There is a right triangle is given to us, sides 5, 12 and 13. The action what is given to us is, we are asked to revolve about the side 12 cm. Means we have to fix that side length 12 cm. Then we have to rotate the triangle. And when we rotate, what is the solid we are getting? That solid volume we have to calculate. So let's try to solve this one. Let ABC be the right angle triangle at B. So ABC is a right angle triangle and AC is the hypotenuse. Hypotenuse means the longest side length we have to put. Here 5, 12 and 13. Out of these three, 13 is the longest one. So that you have to put it in the hypotenuse. Then AB is 12 and BC is 5 centimeter. That is what we have written here. Then we revolve triangle ABC about the side AB. Means we have to fix this side AB and holding this at C, and we just rotate this triangle by fixing the side AB. So we will get a shape like this. Means we are just keeping this AB as fixed and we are rotating this triangle. Means we will get a cone. Means you can see here AB side AB is fixed here and the ABC triangle ABC is here. So when you are rotating, means this way it will be coming and just turning back and coming back to the same position. So the height of the cone remains this one, where we are just axis of rotation, that is here revolving about the side 12 centimeter, means that will be considering as the height, because we are not changing this one, fixing here. And this 5 centimeter will come as the radius, because with this 5 centimeter only we are revolving and forming a circle. So base radius will be 5 centimeter, and this hypotenuse will come to the slant height. So this is the cone, and cone we have to find out the volume of the cone. So radius we have got 5 centimeter, height we have got 12 centimeter. Then we have both r and h, we can calculate the volume, 1 by 3 pi r square h, 1 by 3 into pi into r is 5. So 5 into 5 into h is 12. Then here 3 and 12 we can cancel 4 times. And then balance is pi into 5 into 5 into 4. Pi we are not substituting here, just keep the same. Then 25 into 4 we will get 100 pi centimeter cube. This is the volume of the solid so obtained, that is 100 pi centimeter cube. Move on to the 8th question. If the triangle ABC in the question 7 above is revolved about the side 5 centimeter. In the previous question we have revolved around the side 12 centimeter. Here we are revolving around the side 5 centimeter. Then find the volume of the solid so obtained. The solid so obtained is called the cone. And here whichever the side we are revolving about, that is coming as the height. Another side will come as the radius. Then find also the ratio of the volumes of the two solids obtained in question number 7 and 8. Question number 7 and 8 in two cases are there. The two cases volumes ratio we have to calculate. Here ABC, as we have mentioned before, right angle triangle, right angle at B. Here this is a right angle triangle. The highest side or the longest side we have taken as the hypotenuse, that is 13 centimeter. And there are other two sides 12 centimeter and 5 centimeter. In the previous question, we have formed a cone by revolving this triangle around this axis, that is AB 12 centimeter. And here we are going to revolve around this line or this length BC. So here AC will be the hypotenuse. AC is 13 centimeter, AB 12 centimeter, BC 5 centimeter. This all we have explained. We revolve triangle ABC about the side BC. We get a cone as shown in the figure. So we will get a cone like this. Means we are fixing this one and rotating this way. Rotating this way in the sense this AB will come as the radius, and whichever axis is fixed, that is the height. So here BC revolving around BC. So BC will be the height and this will be the radius and this will be the slant height, that is AC. So radius r is equal to 12 centimeter, height h is equal to 5 centimeter. Then volume of the solid is 1 by 3 pi r square h. Just substitute 1 by 3 into pi into r. R we have changed here 12 into 12 into 5. That is here 3 and 12 we will get it 4 times. When you multiply 4, 12 and 5, we will get it 240. Quite simple calculation. 4, 12 and 5. 5 fours are 20. 20 into 12, 240 pi centimeter cube. Pi we will keep same as here. Then ratio of the volume, that is what we have to calculate in the second part. Find the ratio of the volumes of the two solids obtained in question number 7 and 8. In question number 7 we have got the ratio as 100 pi centimeter cube in the previous question. And volume in question number 8 we have got 240 pi. So let's substitute 100 pi and 200 pi. Then here pi will be cancelled and 20 we can cancel with numbers. Here 100 when we cancel with 20 we will get 5. Here 240 when we cancel with 20 we will get 12. So 5 by 12. So the required ratio is 5 is to 12. Move on to the last question of this exercise. A heap of wheat is in the form of a cone whose diameter is 10.5 meter and height is 3 meter. Find its volume. The heap is to be covered by canvas to protect it from the rain. Find the area of the canvas required. It is a practical question. A heap of wheat. Heap of wheat in the sense just wheat after harvesting, how the wheat it is dumped on the ground. It forms a cone. A heap of wheat is in the form of a cone whose diameter is 10.5 meter, means base diameter, circular portion diameter is 10.5 meter and height is 3 meter. So simply a conical shape is given, 10.5 meter diameter, height 3 meter. Find its volume. So we know the formula for finding the volume. By using the formula, find the volume. The heap is to be covered, means the shape so formed, a conical shape, is to be covered by canvas, means by any plastic sheet, to protect it from rain. Find the area of the canvas required. As we know that something, if it is there in the conical shape on the ground, if you want to cover it, we have to cover the curved surface of the cone. So we have to find out the curved surface area in order to find the area of the canvas. So this portion you will try it as homework. Dear students, today we have discussed volume of cone and we have solved questions from exercise 13.7. Hope it is clear for you all. I request all the students to solve all these questions independently in a sheet of paper while solving. If you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.